Welcome back to Silicon to Software. I'm Imran. Today we're talking about a factory floor 250 miles above your head. Here's how I want to start. A drug got made in space. It landed in the Utah desert, and it came back better than a version made in a $50 million clean room on Earth. I know how that sounds. I thought the same thing, but it's real. It's peer-reviewed, and it's happening right now on the International Space Station. Not in 10 years. Today, let's get into it. Forget astronauts with wrenches. That's not this. Here's the better way to think about it. What if gravity were a bug in your manufacturing process? Because for certain products, it actually is. Gravity causes heavy particles to sink. It creates heat currents that wreck crystal formation. It makes light materials float up and create weak spots. Kill gravity, and those problems mostly disappear. You get purer drugs, cleaner fiber optics, better crystal structures. But don't get it twisted. Space isn't magically clean. Materials release trapped gases in a vacuum. That residue lands right back on your hardware. NASA actually bakes every material before flight to manage this. The contamination problem doesn't vanish, it just changes shape. Heat is brutal too. No air means no convection. Every 90 minutes you get sunlight, then darkness, then sunlight again. That's a constant thermal stress test. And then there's radiation. Cosmic rays and trapped protons that flip bits in memory and slowly degrade electronics. You can't shield against most of it. You just design around it. Redundant systems, hardened compute, error-correcting memory. None of this is unsolved. It's just the cost of doing business up there, and for high-value products, that cost is worth paying. So what does this actually look like today? Varda Space Industries sent up a small capsule in 2023. Target. A crystal form of an HIV drug that's notoriously hard to make consistently on Earth. 7 months later, it screamed back through the atmosphere and landed in Utah. The crystal form held. Better bioavailability, cleaner structure, all built in microgravity. That mission helped Varda raise over $300 million. Redwire Space is doing arguably more actual work than anyone else up there. 11 active payloads on the station. Their additive manufacturing platform has already printed over 200 tools in orbit. But the part that gets me is their bioprinting work. In 2023, they printed a human knee meniscus using live cells. In 2024, they printed heart tissue with no scaffolding at all. In microgravity, soft tissue just holds its shape. On Earth, you need chemical support to keep it from collapsing. That one still sounds fake to me, and it's not. NASA has its own play here too, a program building specialty memory chips using inkjet-style printing and microgravity. Let me be clear, this is not a TSMC competitor. Nobody's challenging cutting-edge chip lithography from orbit. This is about niche, exotic components that are hard to grow uniformly under gravity. Different game entirely. Now the money question. Launch costs have dropped roughly tenfold over the last 20 years. That's the SpaceX effect. But launch price isn't the whole cost stack. Insurance, integration, re-entry, all of that still needs to compress. Still, when your product sells for hundreds of thousands of dollars per kilogram, the math starts working in a way it never does for a communications satellite. Big banks are projecting the overall space economy at $1 to nearly $3 trillion by the 2040s. Manufacturing is the slice of that where you're actually making physical stuff, and it's wide open. Here's something people miss. You can't staff these factories with people. Crew time on the station is scarce and expensive, so everything has to run autonomously. Machine vision, robotic arms, remote monitoring. Today's systems are mostly pre-programmed sequences, not true AI, but that's changing fast, and the companies leading in orbital manufacturing are the same ones investing hardest in autonomy research on the ground. Zoom out for a second. Every major industrial shift needed two things: a new physical environment and a drop in the cost of reaching it. Coal did it, electricity did it, silicon and software did it. I think microgravity paired with falling launch costs is the next one. Now the honest part. The gap between "we proved it works" and "this is a scalable industry" is still enormous. Costs need to keep falling. Return logistics need to become boring and routine. And regulation has been a real drag. Varda's own capsule sat in orbit for months, waiting on a re-entry license. The FAA just consolidated its rules this March, cutting red tape. Licensed launches and re-entries went from 9 a year in 2015 to nearly 200 last year. That's not incremental, that's structural. Gravity will still wreck a crystal lattice tomorrow, exactly like it does today. The only real question is how fast everything else catches up. My bet? Faster than the industry is ready for. That's it for this episode. For the full written breakdown, sources, and all the detail we didn't have time for here, head to silicontosoftware.com. Thanks for listening.